Welcome to Jnanarupa Online Classroom. We are providing online classes for JEE, NEET, MSET, IIT Foundation and CBSE classes. Contact for online classes this number as well as mail ID. Now I am going to explain the motion in a vertical circle. Consider a problem. Consider a body of mass tied to a string of length r revolved in a vertical circle as shown in figure. At all positions of the body, there are two forces acting on it, its own weight and the tension in the string, as well as the track exerts a normal reaction N on the block. Now we'll find out the solution of this problem. So in the problem, a wire is tied on this one. We have to rotate like this one. Then when the body is at the top of the circle, this place, what is the solution? So at the top of the circle, there are two forces are acting on this one. One is the torque due to tension of the wire towards the downside or towards the center, and another one is due to the weight of the body. There is some force is acting towards the center of the mass, center of the circle. That is, these two forces is TA plus mg, and another force is acting due to the rotational force of the body, that is due to the velocity of the body at this place, that is equal to mva square by r. So the overall forces on both are in opposite directions, so that is why TA plus mg is equal to mv square by r. Now by using this equation, TA is equal to mv square by r minus mg. And at normal conditions, the overall tension at any place in the wire is always greater than 0. So TA is greater than or equal to 0. Then we substitute here, the equation becomes mv square by r minus mg greater than or equal to 0. Therefore, VA is equal to, we'll get this equation root of RG. So mg is toward this direction and mm is cancelled on both sides, and we'll get the g here and multiply, cross multiplication RG, and we have to eliminate root here. VA is equal to root RG. Therefore, VA minimum is equal to root RG. This is at point A. At point A, the velocity. Now we'll go for another point, that is when the body is at the bottom of the circle at this point. What is the force acting? So here there are two forces are acting. One force is TA, another force is mg. These two are in opposite directions, so TB minus mg. And another force due to the velocity of the body, that is equal to mv square by r. Now we'll find out here TB is equal to mv b square by r plus mg. Now, if the body is from bottom to top, here the kinetic energy is more and here the potential energy is more. So kinetic energy is decreases and potential energy is increases from this point to this point. This is the given here. Now, so loss in kinetic energy is equal to gain in potential energy. So loss in kinetic energy is represented as 1 by 2 mv b square minus 1 by 2 mv square, that is equal to mg into overall distance between these two is AB, that is equal to 2R. So mg into 2R. So therefore we'll get here m is cancelled on both sides, and 1 by 2 is common here. In this side it will get to 4gr. Now VB square is equal to VA square plus G 4gr. Now VB is equal to root of VA square plus 4gr. And this is also replaced as, for minimum, VB minimum is equal to, this is equal to VA minimum whole square plus 4gr. VA minimum is already given previous gr. So we'll substitute here, we'll get overall VB minimum is equal to root 5gr. Now, the net force towards the center of the body is TB is equal to, from this equation, TB is equal to M by R. VB square is equal to, already VB square is given 5gr, and this is equal to mg, so we'll get 6 mg.